Welcome to the AI Delivery Playbook, advanced concepts for the people who deliver AI in the real world. When should you fine-tune AI models? The delivery decision nobody explains. Fine-tuning is the lever most teams walk right past. Learn to spot the moment it's the right call, and you'll deliver what others can't. The setup. Let's set the stage. First, why AI results so often fall short. Then, the 3 ways you can customize a model to fix it. Why your AI results fall short. You've built with AI, but the results aren't meeting expectations. This shows up on almost every serious AI project. It's a different game than asking AI a question on your phone and reading the answer. You're building an agent. The model is a component inside it, expected to produce reliable output on its own every time. But these models are non-deterministic. Run the exact same input twice, and you won't get the exact same answer. It varies every time, usually close, but sometimes far from what you expected. So the team does what everyone does. They engineer the prompt harder, add more examples, bring in another data source. Sometimes that's enough. But often, no matter how hard they push, the output still isn't consistent enough to depend on. Fine-tuning in one line. Train an existing model on your examples to shape how it behaves. That's where a third tool comes in, and it has a name, fine-tuning. Here it is in the simplest terms. You take a model that already exists. You train it a little further on your own examples. It learns to behave the way you need again and again. Hold on to that. It carries the whole video. A tool most teams don't know about or won't reach for. It sits alongside 2 tools most teams already lean on. One is prompting, just asking a model more clearly. The other is feeding it facts at the moment of the question, which we call RAG. Fine-tuning is the third, and it's the one that gets skipped. Some teams have no idea it's an option. Others have heard of it, but steer clear. It sounds expensive or complex or like someone else's job. So it just never gets picked up, even when it's exactly what the moment needs. Fine-tuning is not how you load your data. Here's the single biggest misconception, and it's worth stopping on. Almost everyone assumes fine-tuning is how you give a model your organization's data, your documents, your policies, your records. It is not. That one wrong belief costs teams in 2 opposite directions. The first, teams overreach. They fine-tune to cram in facts. They spend real money. The model still gets things wrong. Worse, they quietly create a compliance problem they don't know about yet. The bigger mistake, never even considering it. The second and far more common, teams underreach. They keep pushing prompting and RAG and never once weigh fine-tuning on a project where it was exactly the right call. Honestly, that second direction is the costly mess nobody talks about. Underused, high impact, growing fast. Here's the truth. Fine-tuning won't be the answer on most projects. Retrieval does more of the work, but when fine-tuning fits, it makes a real difference, and it's advancing fast. So this isn't a video about avoiding fine-tuning. It's about knowing with confidence when to reach for it and when not to. Why this call belongs to you. Here's the part people get backwards. Fine-tuning is built by an AI engineer, but the decision to fine-tune isn't solely an engineering call. Engineering proves it's feasible and measures how well it works. But whether the cost, the risk, and the trade-offs are worth it, that's a delivery decision. That call is yours. You've never run through the training job yourself, but you cannot make that call well if it's a black box. By the end, a decision you can make on site. So you need to know when it's the right move, why your engineer is asking for it, and when to say, this isn't working, let's bring in someone who can. By the end of this video, You will know exactly when to prompt, when to retrieve, when to fine-tune, and just as important, when not to. Stick with me and you'll walk away able to make this call with real confidence. 3 ways to customize a model. Let's set the scope first so nobody's lost. When I say model in this video, I mean a large language model. It's the kind of generative AI you used inside of tools like ChatGPT and Copilot. The model is the engine, ChatGPT and Copilot are the products built around it. GPT-4o, GPT-4.1, Llama. Those are the ones we mean, not a traditional machine learning model like a fraud detector or a forecasting model. That's a different world with different rules. You customize a model that already exists. You don't build one. We're not talking about building one of these language models from nothing. That's an enormous specialized job that AI researchers do, and it costs a fortune. Ours is the delivery job. We take one that's already been built and shape what it gives us. There are 3 ways to do that. 1 of 3, prompting. Just ask better. The model doesn't change. The model is something you talk to. You send it a prompt, a request in plain words, and it answers. That's prompting. Often asking more clearly is all you need. The model itself never changes. 2 of 3, RAG. Hand it the facts it was never taught. The model still doesn't change. The model sometimes needs information it was never trained on, like your policies or today's numbers. You look it up from a source like SharePoint or a search index and hand it over with the question. That's RAG, Retrieval Augmented Generation. The plain idea? Look it up, then answer. The model never changes. 3 of 3, fine-tuning. Change the model itself by training it on your examples. Sometimes a better prompt and the right notes still aren't enough. You can't rebuild one of these giant models from nothing. What you can do is add to it and adjust how it behaves by showing it a set of your own examples. Not millions, often just hundreds to a few thousand good ones. That's fine-tuning. 3 tools, and choosing between them is your call. So prompting, retrieval, fine-tuning. 3 tools that are not interchangeable. Prompting and retrieval are usually where you start, and we'll cover why. But the real focus of this video is the harder call. Knowing when fine-tuning is the right move and when it isn't. Whether you make that call or guide it, understanding this puts you in the room where the real decisions get made and makes you the person who gets them right. The mental model. Before we get to when to use it, understand what fine-tuning really does. Then the right choice is usually obvious. Once you truly grasp what fine-tuning changes and what it leaves alone, the right call almost makes itself. Own this next part, and you're already ahead of most teams shipping AI today. Retrieval gives the model the facts. Fine-tuning changes how it behaves. Knowledge is what it answers. Behavior is how it answers. Hold on to one idea, and the rest of this falls into place. There are 2 different things you might want from a model. One is knowledge, the facts it draws on, things that can change day to day, like a current price, a new policy, this week's numbers. The other is behavior. This is the one people find slippery, so let me be plain. Behavior is how the model answers, not what it says, but the shape it takes. The format it follows, the tone it uses, the steps it always walks through, the things it always refuses to do. Knowledge you get through RAG, handed to the model at the moment of the question, and the model never changes. Behavior you get through fine-tuning, trained in, baked into the model itself. One honest caveat, so you're never caught flat-footed, fine-tuning, it can pick up some domain language, and task patterns too. It isn't only format and tone, but it's the wrong place for authoritative facts to change or must be governed. So the rule that keeps you safe is simple. Knowledge you retrieve, behavior you train. If that feels backwards, you're not alone. It's the #1 misunderstanding. Now, if your gut just did a double take, if you assume fine-tuning was how you teach the model your company's knowledge, you're in good company. That's the single most common misunderstanding in this whole field, and almost everyone hits it, myself included. For example, 2 things a bank wants: latest rates, which is retrieval, versus house turn, that's training. So let me make it concrete. A bank might ask a model for 2 very different things. The first, use our latest product rates. That's knowledge. It changes all the time, so you retrieve it. The second, always write in our formal tone and our exact memo format. That's behavior. It's stable, so you train it in. Hold that because it's exactly what makes the next mistake so easy to spot. The costly move it leads to: fine-tuning to add facts. That's RAG's job. This is that belief in action, reaching for fine-tuning to load in facts when that is exactly the job RAG exists to do. Get that backwards and everything downstream gets expensive because that fact is baked into the model's weights. The day it changes, there's no quick edit. You have to fine-tune all over again. You can already see it coming, can't you? The moment somebody says, let's fine-tune so it knows our data, you know to reach for RAG instead. Fine-tuning is the most overlooked lever in the toolkit. It rarely even enters the conversation. Now, the mistake I see most often, prompting and retrieval get reached for constantly, but fine-tuning almost never comes up. That's partly fair. It's the right answer for a minority of cases, not most. But those cases are real, and they get missed far more than they should. Not because anyone's careless, but because fine-tuning is the least discussed of the 3. So when the team sits down to pick an approach, no one even brings it up. The goal: spot the project where fine-tuning was the right call and no one made it. So the instinct is to pile more onto the prompt or quietly accept inconsistent output when a fine-tuned model was exactly the right tool. That's the gap I want to close for you, because you're the one delivering this. By the end, I want you able to look back at the project you've already shipped and say, that one. That's where we should have fine-tuned, and now I know. RAG is what you look up. Fine-tuning is what you were trained to do. RAG means looking it up fresh every time. Let's stay with that bank and make it real. Picture a brand new loan officer on the first day at our fictional bank, Pixie Bank. Fictional companies usually get stuck with boring names, not ours. You'll see Pixie throughout the video. A customer asks about today's mortgage rate, so the officer pulls up the current rate sheet and reads it straight off. They never memorize that number. They look it up the moment it's needed. When the rate changes tomorrow, they just read the new sheet. The facts live outside them. Fine-tuning means the house style built in. Now fast forward a year, the way that same officer writes a credit memo. The structure, the tone, the order they walk through risk. None of that gets looked up. It's trained in, from a year of doing it the same way until it's automatic. Now you might be thinking, it could just keep a template on the desk. That's prompting. The example sitting right in front of them. Fine-tuning is a year later when they don't need the template at all. The single rule beneath both stories. You can't point to a single fact they memorized. It's become a habit. That is the whole split. Information that changes, rates, policies, balances, you look up. That's RAG. Behavior you need consistent, at scale, you train in. That's fine-tuning. Fine-tuning teaches a pattern by example, not facts. Hundreds of input and ideal output examples. Here's the part that demystifies the whole thing. When you fine-tune, you're not uploading knowledge. You're giving the model hundreds of example conversations and input and the ideal output you want for it. It trains until it imitates that pattern. Here's what a training file actually looks like. Look at this. This is a realistic sample training file for a credit history summarizer at Pixie Bank. The format has a name, JSON-L, and it's just one example per line, in plain text. Don't let the syntax throw you. Every line has the same three-part shape. The source data goes in, and a clean, standardized summary comes out. Same structure every time. Every line is a tiny three-part conversation. Before we walk a few, here's what one line actually is. A little conversation with three roles. The system role is the standing rules, the same on every line. The user role is the input, the applicant's data. The assistant role is the ideal answer you want back. Rules, input, ideal output. That's every example. A straightforward applicant. Take the first example. A clean applicant goes in, out comes a summary, and a fixed layout, score band, utilization flag, a one-line note, and an advisory-only stamp. That is the shape it will repeat. A hidden question. The model refuses to decide. Now watch this one. The input slips in a question. Should we approve this applicant? A plain model might answer, but every training example refuses. So the model learns to lean the same way. Advisory only. The decision stays with the underwriter. A protected trait Pixie Bank's policy puts out of scope. This input hides a trap. It mentions the applicant is 67 and recently retired. Pixie Bank's compliance policy defines that as out of scope for this summary. So every training example leaves it out and flags it. The model learns to follow that policy. An important part for you, the call about what's in scope comes from compliance, not from the training team. It learns the shape of the answer, then repeats it on new inputs. The goal here isn't to memorize these applicants. It's to learn the shape of the response. Though, beware, models can memorize training examples, especially anything repeated or sensitive, which is exactly why personal data shouldn't casually end up in a training set. Train it on enough of these, send it a brand new applicant it has never seen, and it produces that same format far more consistently with a much shorter prompt. One thing to hold on to, though fine-tuning shifts the odds, it doesn't make the model deterministic. It makes the behavior you want much more likely, not guaranteed. So anything contractual, regulated, or safety critical, a JSON schema, a regulated memo, a refusal you're relying on, still has to be validated and enforced outside the model, not just trained in. The process, start to finish, upload, train, get a new model. So what actually happens with that file? At a high level, it's simpler than people expect. You hand a file to a platform like Microsoft Foundry. You pick the model you're starting from, and you kick off the training job. The platform does the heavy lifting. When it finishes, you have a new custom version of that model, and your agents call it like any other. I've put Microsoft's official step-by-step walkthrough in the description, so if you want to see exactly how it's done, it's right there. That's the whole mechanism in one idea. That is fine-tuning. You're teaching habits by repetition, not facts by explanation. Let me be clear about what this video is. That file is about as deep as we go on the how. I'm not trying to make you a data scientist or an AI engineer. I'm making you the person who knows which path to take and why. A light look at how it works inside, like this one, is all you need to direct the work and judge whether it is being done well. That mental model is the thing most teams never stop to build. You have it now, and everything ahead is just putting it to work. The decision ladder. 3 levers to improve output: prompt engineering, RAG, fine-tuning. Lever 1. Engineer the prompt. Cheapest? Start here. Here's the framework you'll actually use on your next project. First, one gut check before any of it. Are you even on the right model? It's worth testing a stronger model and a smaller one against the same cases. Sometimes a better base model solves the problem outright. Sometimes a smaller one is what makes fine-tuning worth it later. Once you're on the right model, you have 3 levers to improve what it gives you, and they go in order of cost. Start by engineering the prompt. It's the cheapest and solves more than you'd think. Add RAG or fine-tuning only when a better prompt can't get you there. Get that order right, and you'll save most teams a fortune. Lever 1. Engineer the prompt. Your first lever is the prompt itself. You always have one, so the move is to engineer it. Sharpen the instructions, add examples, structure the request. You'd be surprised how many problems that solves on its own. It's the lowest cost lever too, though not truly free. Long instructions and repeated examples cost tokens and latency on every call. Most problems stop right here. Before you spend $1 of your delivery budget on anything heavier, prove that a well-engineered prompt can already do the job. Most of the time, that is your answer. Lever 2. Add RAG when you need facts. Lever 2. Does it need to look things up? Reach for your second lever only if a better prompt wasn't enough. Do you need the model to use fresh facts, proprietary information, or to cite its sources? Then you want retrieval. Here's how it works. You pull the relevant knowledge from your source, add it into the prompt alongside the question, and the model answers using that data. The model itself never changes. Any repository counts. It's still retrieval. It doesn't matter where those facts live. A search index, a document library like SharePoint, a database, a knowledge base. Pulling them in at the moment of the request is retrieval. The source is just an implementation detail. Knowledge that changes or has to be traceable belongs in a retrieval layer, not baked into a model. To add knowledge, retrieval beats fine-tuning. This isn't just preference. A 2024 study by Ovadi and colleagues put it to the test. Across a set of knowledge-heavy tasks, retrieval consistently beat the fine-tuning approach they tried for adding facts, and that approach struggled to generalize new ones. Which is the whole point. Fine-tuning was never the tool for facts, for knowledge retrieve, save fine-tuning for behavior. Lever 3. Fine-tune for consistent behavior. Lever 3. Only now does fine-tuning belong. Your third and heaviest lever, and it's the last one you reach for. You've engineered a prompt, you've added retrieval if the task needed facts, yet you still need more consistent behavior or format at scale on a stable repeating task. Only now does fine-tuning earn its place. The telltale sign you've hit that wall. Here's a simple way to recognize that moment. If you find yourself pasting the same examples into the prompt over and over, what's called few-shot prompting, just to hold the output together, that's the signal. Fine-tuning is like taking those examples and baking them permanently into the model, thousands of them instead of 3. So you stop paying for them on every single call. Microsoft names that exact path in their own guidance. What's it really for? The list of jobs fine-tuning is generally worth it for is short and knowable. Shortening bloated prompts, locking in a format or schema, nailing a brand voice or tone, making tool use more reliable, or fine-tuning a smaller, cheaper model to do one job as well as a pricey one. One caveat on format: if all you really need is valid JSON or a fixed schema, reach first for the platform's structured output or constrained decoding feature. Where the model supports it, it can enforce the schema directly, though you still handle refusals and wrong values inside the fields. Fine-tuning is for the harder job, getting the right content and decisions inside that shape consistently. Several methods exist, and modern LoRa makes it far cheaper. There are a few different flavors of fine-tuning, and they matter. I'll break them down in just a minute. The budget news keeps getting better. Modern techniques like LoRa, which trains a small add-on instead of the whole model, make this far cheaper than it used to be. Before anyone fine-tunes, insist on 4 things. First, the baseline of how well the simpler levers already do. Prompting and retrieval if the test calls for it. Second, a set of test cases the model won't see during training. Third, a success metric the business will actually accept. Fourth, representative training data you actually have the right to use. No baseline, no held-out test, no metric, or no trustworthy data, no fine-tune. You don't need to run this yourself. You need to know it's feasible, when it's worth it, and what to demand before it starts. Independent levers: RAG for facts, fine-tuning for behavior. Use one, the other, or both. Independent levers: use one, the other, or both. One last thing, and it's the payoff. Treat RAG and fine-tuning as independent levers, not a packaged deal. You might use retrieval on its own, fine-tuning on its own with no retrieval at all, or the two together. Whatever the problem actually needs. They fix different problems. RAG supplies knowledge the model lacks, fine-tuning shapes how it behaves. Because they work on different things, their strengths stack instead of canceling out. And a large industrial study on real code tasks across a huge internal code base, researchers found the two are complementary. Combining them beat either one on its own. So when a project needs fresh facts and consistent behavior, reach for both. When it needs only one, just use that one. Climb only as far as you need. That's the discipline. So the latter isn't prompt versus RAG versus fine-tuning. Pick one and fight. It's a sequence. You climb only as far as the problem demands. Engineer the prompt first. Always add a retrieval if you need the facts. Fine-tune if you need behavior. Combine the last two when you need both. You skip any rung your problem doesn't call for. That order and knowing when to stop is the whole discipline. Learn to climb it, and you can walk into any project and know exactly what to try next. That's not theory you're carrying now. That's judgment. If you're enjoying this, please like and subscribe so the next video finds you. Now let's keep going. Method and model. You've decided to fine-tune. 2 things to get right next. They're the 2 an AI engineer will assume you already know, which kind of fine-tuning the job actually needs and whether your model even supports it. Learn these 2 and you can hold your own in any conversation about it. There isn't one fine-tuning, there are 3, and they're not interchangeable. One name hides 3 very different tools. Fine-tuning is really an umbrella over 3 methods, and the difference is simply what you hand the model to learn from. Know enough to steer the conversation. A quick word on altitude before we go in. This next part is genuinely AI engineering and data science territory. Unless you're in one of those roles, you will never configure these yourself, and you don't need to. But a high-level grasp of the 3 is exactly what lets you follow your engineer's recommendations, push back on it, and match the method to the job. Method 1. Supervised fine-tuning. Your default. The first and the one you'll use most is supervised fine-tuning, SFT. That's the example file we just looked at. You give it the input and the ideal output. Then it learns to imitate the pattern. Start here for almost everything: format, tone, a domain task. Method 2, preference tuning. Learn from a choice. The second is preference tuning, or DPO. Instead of one right answer, you give 2 responses to the same prompt and mark which one is better. Do that across many examples, and it learns to lean towards the kind of answers you want. More on brand, more helpful, or safer. But safety only counts here when it's actually represented in the preference pairs and the evals. Method 3, reinforcement fine-tuning. The newest of the 3. The third is the one getting all of the attention right now: reinforcement fine-tuning, or RFT. Here's the mental shift. Supervised fine-tuning shows the model the answer. Reinforcement fine-tuning only tells it the score and lets it figure out how to win. Where RFT wins: objectively scoreable task. With reinforcement fine-tuning, you hand over a grader, something that scores the model's attempts, and it experiments until it learns to maximize that score. That makes it powerful for problems you can score objectively: tool calling accuracy, structured extraction, rule following where the right and wrong are clear-cut. The catch is the grader itself. RFT only works when success can be measured reliably, and the weak grader just teaches the model to game the score. The reasoning model O4 Mini is the visible example. GPT-5 reinforcement tuning is in Foundry's Table 2, though the access is gated, so check the live list before you promise a method. Match the method to the job. One placement rule worth knowing: Microsoft positions reinforcement fine-tuning for complex, objectively gradable reasoning tasks, not for tone or style. Those belong in prompting or in supervised or preference tuning. Method versus mechanism. SFT, DPO, RFT are methods. LoRa is how. One clarification, because you will hear these names used a lot, especially as a consultant or a manager on a delivery. Those 3, supervised, preference, reinforcement, are the methods, which you train a model on. Remember, LoRa, the cheaper technique I flagged a minute ago, its full name is low rank adaptation. It's not a 4th method, it's an efficient technique, and here's the intuition for why we use it. The technique that makes it affordable. Quick definition, because it matters here. A frontier model is one of the biggest, most capable models at the cutting edge. GPT-5, Claude, Gemini, or Grok, the kind behind tools like ChatGPT. Fully fine-tuning one means adjusting all of its billions of parameters, which is heavy and expensive. LoRa leaves that giant model frozen and trains only a small add-on that layers on top to shift its behavior. So you get the tuned result without paying to move the whole model. Microsoft documents it for supervised fine-tuning. Don't assume every provider or every method uses it inside. The old SFT only rule is dead. A quick myth buster. It used to be true that Microsoft only offered supervised fine-tuning. Today, Foundry supports all 3, but support is model specific, which is exactly why you check the table. The method you need may only exist for certain models. So when someone says we're looking to do a LoRa fine-tune, that is the cheap, efficient kind, a good sign for your training budget. This isn't only a Microsoft story though. The other major clouds each have their own tuning menus, and we'll map those in a minute. Know the answer? SFT. Pick the better? DPO. Score it? RFT. Here's the whole thing on one line. Supervised when you already know the ideal answer. Preference when a human can pick the better of 2. Reinforcement when a grader can score success. Which is this whole video one level deeper. Match the method to the job. Just like that, you can tell apart three methods that are easy to blur together. How do you know a model can be fine-tuned? You check the list. First, let's clear up one term: foundation model. Now, a question I get constantly: how do you even know if a given model can be fine-tuned? Let me clear up the vocabulary first, because it trips some people up. A foundation model is just a model pre-trained on a huge amount of data. GPT-4.1, GPT-5, Llama. That word tells you nothing about whether you can tune it. The label isn't the real test. Quick plain English aside first. A model's weights are simply the billions of numbers it learned during training. Think of them as internal settings. What matters for you isn't the math, it's whether those settings are open or closed. Open weight models, Llama, Mistral, Phi, Quen, you can often tune outside the original provider if the license and tooling allow. Closed weight models like selected GPT models, you can still fine-tune, but only through the provider's managed service. You never touch the weights yourself. But in practice, fine-tunability isn't a vocabulary question, it's a product support question. License, model version, region, and method all have to line up. The reliable way to know for sure. When you do tune one, the model you start from is called the base model, and what comes out is a new custom version of it. So how do you know in practice? You don't guess, you check the provider's supported models list. Read it, and the guesswork is gone. This is Microsoft Foundry's current published support table. Look what it tells you: which models you can tune and which method you can use. Supervised here, reinforcement there. So the next time you see a Foundry release that says fine-tuning is now available for some new model, now you know exactly what that means and whether it fits the method your project actually needs. One caveat worth saying plainly: a list like this changes as new models ship. So treat the version on screen as a snapshot, and check today's before you promise a method. The discipline is portable, the tooling differs. One skill, every cloud. One last point, because you will deliver on more than one stack. The decision you just learned is portable, the tooling is not. Azure, AWS, Google, each does it their own way. On Microsoft Foundry, you get supervised preference and reinforcement tuning. The three methods we just covered, AWS Bedrock and Google Vertex, take their own routes, and AWS even adds distillation, which just means using a big model to train a smaller, cheaper one to do a single job well. Not every platform offers every method, so confirm the exact one your project needs actually exists on the stack you're on. The through line on every engagement. The same judgment carries, but the data contracts, the eval gates, and the deployment mechanics differ on each stack. So lead with the discipline, prompt, then retrieve, then fine-tune, and combine the last two when you need both, and let the platform be an implementation detail. That's how you stay sharp, no matter whose cloud you are standing in. When not to. The expensive mistakes, the honest cost, and the risk nobody warns you about. This last part is the one that separates teams who deliver from teams who stall. Knowing when not to fine-tune is worth more than knowing how. And it's the judgment that will make people trust your call. Don't fine-tune to add facts. The headline mistake, the one we opened with, do not fine-tune to add knowledge. Facts change. Weights don't update on their own when they do. While this rule is non-negotiable, the moment a price, a policy, or a regulation updates, a model with that fact baked in is now confidently wrong, and you have to retrain to fix it. Knowledge goes in the retrieval layer every time. If you remember one thing from this video, make it this one. Fine-tuning's real cost is a trade-off plus 3 quiet risks. The honest cost has 2 sides. Here's the part most estimates get wrong. Fine-tuning does carry real overhead. There's the training run. Then a fine-tuned model has to be hosted, maintained, retested, and eventually migrated. That's an MLOps discipline. It's the same production lifecycle work any deployed model needs. When the base version it's built on nears retirement or a newer model offers a real gain, you may need to tune again. But there's a flip side. Once it's trained, your prompts get shorter, so calls get cheaper and faster. The real question isn't cost, it's break even. It really comes down to volume. Do you run enough calls for the per call savings to outweigh the overhead? At high volume, an enterprise hitting the model all day, fine-tuning can be the cheaper option overall. At low volume, prompting or RAG usually wins. That's the judgment you own. When the technique fits, but the delivery doesn't. This next one is pure delivery judgment. Sometimes fine-tuning generally fits the problem and you still pass on purpose. It brings overhead most estimates miss, a specialized skill set on the team, and the disruption of bolting a training pipeline onto a project whose budget, scope, and timeline are already locked. Dropping that into an in-flight delivery can cost more than it saves. Knowing that difference is a call only you can make. 3 quiet risks, 2 technical, 1 legal. First, catastrophic forgetting. The model can get worse at things it used to do well, even with the cheaper methods. Second, safety regression. Fine-tuning an aligned model can weaken its guardrails, even when nobody intended it. That's why you must retest safety after every fine-tune. Don't assume it carried over. There's a third, quieter still, and it's a legal one. Data baked into the weights can't simply be deleted. I'll come back to that one. It's the risk that can actually stop a launch. The platform has a safety backstop, with a catch. On that, Microsoft Foundry offers a safety gate, currently in preview. It can scan your training data before the run and evaluate the finished model before you deploy, and block it if either crosses a harm threshold. Treat it as a useful backstop, not a guarantee. It does not replace your own evaluation. A hidden legal exposure in fine-tuned models. The one that should really stop you as the person accountable for shipping this. Data baked into weights cannot simply be deleted. You may be able to delete the training file or retire the whole custom model. What you usually cannot do is remove one person's contribution from the learned weights the way you delete a row from a database. Under right to erasure rules like GDPR, that can become a real compliance exposure. The right isn't absolute, and whether you'd actually have to touch the model is a case-by-case legal question. That's exactly why personal or regulated training data needs a privacy and legal review before you tune, not after. The single most valuable call you'll make. That is exactly the moment to bring in a specialist. When a project touches regulated or personal data, when you're reaching past basic supervised tuning into preference or reinforcement methods, when the output is safety critical, when nobody can name the success metric, or when a model gets quietly worse after a tune. That is when you stop and bring in the right specialist. It isn't always a data scientist. It might be applied ML for the tuning itself, privacy or legal counsel for personal data, or safety and domain experts when the call is regulated or safety critical. Knowing that moment and who to call is the whole job. The takeaway. You've got the full picture now. Here's what to take with you and what to do on your very next project. What you can do now. The judgment you just built. Look at what you can now do. Someone asks, should we fine-tune this? You have an answer. Prompt first is often enough. Use RAG when you need facts, fresh data, private data, something you can cite. Fine-tuning when you need behavior, the same format, the same tone, again and again. Combine them when you need both. Never fine-tune just to add facts. The takeaway that outlasts the rest. Here's the one line to remember. Fine-tuning isn't how you give a model your data. It's how you give a model your habits. That single distinction, knowledge versus behavior, is your test. Needed to know something, retrieve it. Needed to behave a certain way consistently, that's when you train it. Get that one call right, and you'll spot the expensive mistake a mile away. Feel the difference from when you started? Think about where you were when this video started. This is the decision teams get wrong all the time. Expensive, quiet, hard to undo. Now you can see it coming. You can walk into that room, hear an engineer say, let's fine-tune, and ask the 3 questions that matter. Is it behavior or facts? What will it cost? How will we know it worked? That's not a small thing. That's a judgment most people in these projects never build. Now you know when to fine-tune and when not to. That's what this channel is for. Giving you, the person who actually delivers this, the calls that make or break a project. So the next time this decision lands on your desk, you won't guess. You will know. Most teams never reach for fine-tuning. Now you reach for it at exactly the right moment and deliver what others can't. That's your edge. Thank you for spending time with us. Like and subscribe. Stay sharp, stay Azurite. See you in the next one.